Hey everybody, here goes a video on radical review and then introducing you to what rational exponents are. So to start, I'm going to show you my favorite way to simplify radicals. Back in the day, you've probably learned it a few different ways. I always use the factor tree. Here's why. When you first learned, you might have done the square root of 4 times the square root of 2 will give you the square root of 8, and the square root of 4 is 2, so 2 root 2. But how would you like to do that when the smallest sixth power is 64? That's not going to be really easy to memorize your smallest sixth powers or fifth powers to divide by. The factor tree will work for all of them. So I'm going to start out by reminding you guys how to do that. Little trick someone taught me is always divide by the smallest number. It'll make it nice and organized. So 8 can be split into 2 times 4. 4 can be split into 2 times 2. If it's a square root, you circle pairs of the same number, box any leftovers. The pairs go out together, so you have a pair of 2's that go out, the box stays inside, so you get 2 root 2. So we get the same answer. The nice thing is it works for any kind of root. So we have 32 could be 2 and 16, and then we have 2 and 8, 2 and 4, 2 and 2. If you keep it in a nice, easy flow, we just have to circle 3 at a time now. So we have 3 2's. And then we have leftovers. You need to circle groups of 3. Not going to work. So we're going to have 2. And then we have 2 2's, so we have root 4. But of course, that's a cubed root, so make sure you have a little 3 in the index of that radical. Last one, 96. We've got 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Circle 4 at a time. That group of 2's goes outside. You have a box 2 and a box 3 because there's not enough for a group of 4. So that's the fourth root of 2 times 3 is 6. So I know a lot of you learned how to simplify radicals using the factor tree. Just wanted you to know that it could apply to any type of root. So let's make this Algebra 2 trig now and let's start simplifying again. So you're going to have to deal with exponents and variables. No worries. The square root of 4 is still 2. No big deal. However, when you're taking the square root or the cube root, you're dividing. So we have 2 divided by 2 evenly becomes 1. And then 5 divided by 2 is 2 with a remainder of 1. So you can take out y squared, but you have to leave 1 inside. So we have 2xy squared, square root of y. Done. Next one. We have 4. 4 divided by 4 is 1. 7 divided by 4 is 1 with 3 remainder. So we have a y outside, and we have a fourth root of y to the third power. 8 divided by 4 is 2 evenly, so we can take out a z squared. Done. When you have a number, still treat a number like a number. So you can use a factor tree, or I'm going to show you a super sneaky shortcut that you can use if you want. 64, by the time you're done with this unit, you're going to be pretty familiar with the fact that that's 2 to the 6th power. So you can rewrite that as 2 to the 6th. And then we have x squared, y to the 5th, z to the 7th. Now you can treat it the same way. 6 divided by 5 is 1, so we can pull out 1, 2. And then you have to leave 1 inside because there's 1 remainder. Now, if you would have simplified that, you would have gotten 2 root 2 anyway, so it's no big deal. 2 divided by 5 is nothing with 2 remainder, so we keep the x squared inside. 5 divided by 5 is 1. And 7 divided by 5 is 1 with a remainder of 2. Done. So again, either way you want to do it is totally fine by me. You can break it down, whatever works. Okay? So when you're adding and subtracting or multiplying, there's a few rules you need to know. When you multiply, you can multiply them together just as long as they have the same index, same type of root. So the cube root of 4x times the cube root of 2x squared, we're just going to multiply. So 4 times 2 is 8, so we have the cube root of 8. And x to the first times x squared is x cubed, because when we multiply, we add exponents. But then you have to simplify. The cube root of 8 we know is 2, and 3 divided by 3 is 1. Done. So your answer is 2x. When you add, it's like adding variables. So we can't add 2 root 2 plus 3 root 3. That will not work. Pretend this is like an x. 2x plus 3x is 5x. So if you have 2 root 3's plus 3 root 3's, we actually have 5 root 3's. Okay? So when adding, you need to have the exact same radical, and you just add the leading coefficients, just like 2x plus 3x. Okay? So you're probably looking at this next one, and you're like, well, those are different. I can't add them. Not true. The first thing you must always do is make sure that you have the radical in its simplest form. If we were to break down the 4th root of 32, we would end up with 2 4th root of 2, because that's technically 2 to the 5th power. Or if you were to break it down with the factor tree, you would have 5 2's. So you would circle 4, bring it out, and box 1, leave them inside. So for this one, we're going to end up with 5 4th roots of 2. Okay? So not too different than what you've done in the past. I mean, you know, when you're adding variables, they've got to have the exact same one, same exponent and everything. So the rules will be very similar for that. Last 3 on the radical review are what you do when you divide. So remember, one of the rules you learned is you're not allowed to have a radical in the denominator. So, a trick you learned was to multiply the top and bottom by the square root of 3. And that works. But not when you get to cube roots, 4th roots, and all that kind of stuff. I'll show you why in a second. So the square root of 3 times the square root of 3 would be the square root of 9. So we have 2 root 3 over square root of 9, which is a perfect square. Square root of 9 is 3. So we have 2 root 3 over 3, and we're done. Now I want to show you why that doesn't always work. It only works exactly that way if you're working with square roots. If you try with a cube root, you're going to multiply the top and bottom by the cube root of 3. And you get 2 cube roots of 3 over the cube root of 9. And the cube root of 9 is not 3. So you still have a radical in your denominator. So how do you fix that? Well, how do you take a perfect cube root of 3? You need to take the cube root of 3 to the 3rd power, because 3 divided by 3 is 1. Disappears. So we need the cube root of 3, which would be 27 if you want to think about it that way. So to make it easier, you have 3 to the 1st power. How many more 3's do you need? You need 2 more. So the answer to this question is actually 2 cube roots of 3 squared, also known as 9, over the cube root of 27, which we now know is going to be 3. Okay? So that's where the tricky part comes in. When you are working with 4th roots, 5th roots, anything other than a square root, you have to think about how many you need to make it a perfect whatever root you're working with. So this last one, you might want to multiply the top and bottom by the cube root of 9 squared, 81. But why would you do that? That's too big. Let's rewrite that question. That's 2 over the cube root of 3 squared x to the 1st power. That's going to be a nice time saver. Now, if you were to multiply the top and bottom by the cube root of 81, you would have to go simplify it when you're done. So the cube root of 81 is going to give you 3 cube roots of 3. So you might as well just simplify it from the beginning. So now when you multiply the top and bottom by the cube root of something to give you a perfect cube root, you've got 2 3's already, so you only need 1 more. But you've only got 1 x, so you need 2 more x's. So that's going to leave you with 2 cube roots of 3x squared over, now again, 3 squared and 3 is 9 times 3 is 27, so the cube root of 27 is 3. And x to the first times x squared is x cubed, and the cube root of x cubed is x. So again, no more radical in the denominator. But the craziest one is when you have a plus or a minus sign. In order to get rid of that, you need to multiply both the top and bottom by what is known as the conjugate, which means the 3's stay the same. The root 5's stay the same, but the plus sign turns into a minus sign. Show you why as we work it out. So, distribute the 2, 6 minus 2 square roots of 5 over. You have to FOIL the denominator. So you have 3 times 3 is 9. 3 times a negative root 5 is negative 3 root 5. 3 times a positive root 5 is a positive 3 root 5. And a positive root 5 times a negative root 5 is a negative root 25. Remember, we can multiply. So, the reason why it's a conjugate is because those will cancel each other out. So we have 6 minus 2 root 5 over 9 minus the square root of 25. Well, the last time I checked, square root of 25 is 5. So 9 minus 5 is 4. So we have 6 minus 2 root 5 all over 4. Split. 6 over 4 minus 2 over 4 is going to give you 3 over 2 minus 1 square root of 5 over 2. Okay? Now I know that was a long video, but that was only the radical review. That is essential skills of radicals that you need to have to be able to work with the rest of this unit. Okay? So tell you what we're going to do there. We are going to stop this video right now on just the radical review. And in another video, we will do the introduction to rational exponents. Okay? Temporarily, this is Longo and I'm out. See you, bye.